So today's class is going to be one very loaded class. So when I say loaded class, what I mean is this is a class in which we will talk about trigonometric functions, we'll talk about unit circles and see how do we marry them together, and then we'll also touch upon a little bit of geometry, which is a very important part of the topic that we're going to cover. So while we're waiting for some of the kids to join still, let me start with one or two building blocks, okay? Or not two, actually three. If I ask you guys, do you remember what is the Pythagorean theorem? I hope the answer will be yes, correct? Everybody? If I say what is the Pythagorean theorem, you will say that please don't ask simple questions. When we are talking about a right angle triangle and these are the sides A and B making the right angle, Pythagorean theorem says a squared plus b squared equal to c squared. This is one of the building blocks. Everybody knows about it. I was just helping you guys to recall it. This is one. Look, Saranya. Okay. So this was we are starting with. In today's class, basically we are going to talk about basics of trigonometry. We'll talk about unit circle, and then we'll talk about how do you find out some of the commonly used angles value or trig functions using the basic concepts that we are aware of. Okay? All right. So I see some kids walking in. Just 10 more seconds. Guys, quick. Okay. All right. What happened? Saranya got scared. Have a seat, settle down quickly. We are 4 minutes into the class. So it's okay. So this is the spray for keeping the mosquitoes away. Just check if it is not hurting before you rub it on all the exposed parts of your body. Oh, not that much, not taking bars with that. Alright, on your feet probably. Okay. Alright, so in today's class, Saranya, can you hear me okay? Okay. So we have not missed anything so far. I'm just doing a quick recap of some of the things, some of the building blocks of what we're going to learn in coming weeks. So first one I touched upon was the Pythagorean theorem, and I'm pretty sure that everybody knows about it, so I'm not going that far with that. Second one is SOHCAHTOA. Is everybody able to recollect what I mean by SOHCAHTOA? So this gives you the basic definition of how you find the relationship between the sides and the angles. So what is sine of any angle? Let's say if I'm taking this as an angle, sine of theta would be opposite side divided by hypotenuse. So this is the side opposite to this angle that we're talking about, A over C, opposite side by hypotenuse. Cos of theta would be equal to adjacent side by hypotenuse, that is adjacent side is B by hypotenuse C, and tan theta would be equal to opposite side by adjacent side, so A over B. And I know you guys very much know about it, but I was just setting the foundation before I start building a big house. Okay, so these two. Now there's one more theorem of congruence. If I have two triangles, if I say they are congruent, there are four ways you can prove whether they are congruent or not. First of all, what do we mean by congruence?
They're equal.
Exactly the same. Exact replica of each other. Everything matching. Am I making sense to everybody, or I'm just convincing myself so far? Hey Vishal. Ananya, Samriddhi, Vishwa, Dev, Saranya, Vishal, everybody. Vishal just joined just now. So what I was saying was, we are going to talk about trig functions and use the unit circle concepts to relate them and see how do we use them actually. So before I start teaching anything, guys here, everybody here. Before I start teaching anything, I was just doing a quick check of what we know. So this is the Pythagorean theorem I talked about. I know everybody knows about it. I talked about SOHCAHTOA, and now I'm talking about the theorem of congruence. So before I go into the depth of what is theorem of congruence, first of all, do you guys recall what do we mean by congruence? And the answer I got was that when you say any two shapes are congruent, they're exactly the same. They're a copy of each other. They have each and every property matching. Yeah. Now, to support that theorem of congruence, there are 4 theorems. At least with respect to triangles.
Side angle side. Angle side angle.
Angle sides.
Angle side is the same thing. I mean here it's like 2 sides and the angle between them.
And then just the other way around.
RHS.
What is R?
RHS is the theorem that applies for right angle triangles. So it says 2 right angle triangles will be congruent if the hypotenuse matches and one of the side matches.
Wait, isn't it SSA?
No.
SSS.
No.
SSS is the first one. All 3 sides matching is fine.
There's no AAA or ASS.
No, there was an AA.
No,
Or was that for
There is no
symmetry?
AAA. AAA
Oh,
makes
no.
the triangle similar.
There's only AA possibly.
I'm sorry?
There's only AA, right?
Angle,
A
angle.
AA postulate.
angle side angle. Or angle side also I don't mind. I mean theorem says angle side angle meaning 2 angles and the side between them.
I feel like I've seen RHS before. I don't remember.
Okay, so let me do one thing. I will close the door. I'll seek your help to close the door, garage door, okay? If you don't mind. So that all the unwanted students I have in the shape of mosquitoes will keep them away. So okay. So I'm going to spend, we are going to spend 10 minutes on this congruence. Okay. This is a very, very important part of geometry and trigonometry. And if you are clear about it, it'll help us do things in a much easier way. So when we are talking about congruence, I'm keeping it focused to congruence of triangles. Okay. So if I have 2 triangles, what are the circumstances under which I will say that they are congruent? These are the 4 theorems that say so. If you have 2 triangles, all the sides matching, they are congruent. Is everybody with me?
You could also use this for like a square when using the elusive property or something, like the line in the middle is equal to itself.
Right. No, we will come to that. We will see the application of it. I might not be able to recall what you are saying, but we will see the application of it. I might be able to relate it. So first theorem is when you have, it says, these are the theorems for congruence of triangles. Is everybody with me so far? Ananya, Saranya, Samriddhi, Vishwa, Dev, everybody? Vishal. So first one says if you have 2 triangles where all the 3 sides are matching. So if I have 2 triangles, let's say this and this, if I am claiming that they are congruent, that would mean that one side here and one side here matches. Second side here, second side here matches. Third side here, third side here matches. If that is the case, they are congruent, and then we can blindly say that each and every other property will match. Every other angle will match, the area will match and everything. This is the first one. Second one says, I'm not going to prove that, okay? I have proved how the theorems are derived, but I'm not going to do that in this class. If anybody needs that confirmation we can do that outside this class. If we have two triangles where I'm talking about SAS, meaning side, angle, side, meaning take any two sides, this side matches, this side matches, and the angle between them, if they are matching, then these two triangles will be congruent. Okay? If you see that this information says that these two sides and the angle between them matching, then you can assume that this side will be the same, this angle will be the same, this angle will be the same. If you are talking about the third theorem of congruence, that says if you have two triangles where the two angles and the side between them, meaning if you take this angle and this angle matching, this angle and this angle matching, and the side in between them are matching, then they are congruent. Let me not complicate this. This angle and this angle are matching, this angle and this angle are matching, and the side between them are matching. Then they are congruent. So here you can take a little diversion as well. So you can say that, okay, I don't care about the side being in between. AAS is also fine, because if your two angles are matching, the third angle will match by default. So even if it's any two angles and the one of the side matching, you are still fine. Okay. Okay. Is that okay? Okay. All right. So, but for the sake of simplicity, two sides and the angle between them, two angles and the side between them. And I'm not proving it. I'm not asking you guys to memorize this. I have proved that in the previous classes. In this class, I'm not proving it. In future, if you need to, I can prove that for you guys. Now, the last theorem says, this is R stands for right angle triangle. So this one is very much particular to the right angle triangle, which says if you have two right angle triangles, and the hypotenuse of both the triangles match, and any side, be it this side matching, or be it this side matching, doesn't matter. If the hypotenuse matches, you just need one side to match. Everything else will fall into place. And you can see that. This is the reason why I was talking about this one.
Oh, it's just HS. Okay, I remember that.
Yeah?
I didn't remember the R.
Yeah. So R just makes it point blank, saying that, okay, if you have a right angle triangle, then this is specific to that. So I see somebody with name Enoch. Can you tell me your name?
My name is Enoch.
I'm sorry?
No, my name is Enoch.
Enoch, okay. And is your daddy's name Wasawa?
What's it?
I just wanted to know your name. Oh, is your mom's name Janet?
Yeah.
Oh, okay. Yeah, I talked to her a couple of days ago. Okay, good. Welcome to have you in the class with her. Okay? Alright, so this is the class where we are talking about, we are starting a unit called trig functions and unit circles. Okay? So I just touched upon one of the things that you guys need to know as a base. So I help the kids refresh what is Pythagorean theorem that I believe everybody knows. I just touched upon what is SOHCAHTOA, which I assume Enoch you also know. Yeah? And I'll probably call out your names more often because this is your first class, just to make sure that you're with me and you're able to follow me, okay? So I'm not putting you on the spot. This is what happens when any child joins for the first time, alright? So don't worry about that. My questions are just to make sure that everybody is on the same page. And then we are talking about the theorem of congruence, meaning theorem of congruence of tables. So there are four theorems that I talked about. SSS, SAS, ASA and RHS. SSS says if there are two triangles where all the sides are matching, meaning all the three sides here have an equivalent side here, then they are congruent. If there are two triangles where two sides and the angle between them matches, they are congruent. Two angles and the side between them matching between the two triangles, they are congruent. And this one is specific to right angle triangles, where if there are two right angle triangles and the hypotenuse matches and one of the side matches, they are congruent. This is just a prelude to what we are going to learn in the class today. Is that okay? Enoch, again, I hope I'm pronouncing your name right, okay? It takes me a couple of classes to make sure that I don't mess up with the names. Bear with me. Okay? So let's keep this as a backbone of what we're going to learn. Now I'm going to talk about some of the trig functions, and you would know that, okay, sine of 30 degree, sine of 45 degree, sine of 60 degree, sine of 90 degree, and then same thing with cos, and then sine of 0 degree also, cos of 0 degree also. So we are going to derive or find out how do we get the value of these trig functions, applying the basic concepts that we are aware of. Is that okay so far? Enough, you'll have to be a little more participative with me. Yeah?
Yes, sir. Sorry.
Yeah. No, it's okay, Vita. I'm just trying to make sure that everybody is with me, okay? And here in the class, you don't have to worry about taking notes or anything, because whatever we are doing, whatever I am doing, along with the board, is getting recorded, and I'll be sharing the video of the class afterwards, so that you can anyways use that for revising what we did. So don't worry about taking notes. Focus on following the concepts and arguing with me if you see anything that is contentious. All right?
Okay, sir.
Yeah. So I'm saying let's try to find out what is the value of sine 30 degree, sine 60 degree, cos 30 degree, and cos 60 degree. How do you find it out? And this time I'm saying, and why we're trying to find out the value of these angles, primarily because why we're trying to find the value of these trig functions is because these are one of the most commonly used trig functions. You guys have the luxury of having a calculator. I never had calculator till my engineering days. So these things we learn how to derive. Okay? Does anybody know how do we derive this? How do you find it out? You know SOHCAHTOA, but does that help you find it out? Think about it. Okay. Let me start with some scratch work. Okay, if I say this one is an equilateral triangle, you guys will go mad. This looks a little bit like an equilateral triangle, does it?
Yeah.
Accept it. And Sahit, you might want to move a little bit to this side. I'm struggling to make eye contact with you. Okay, so this is the this is an equilateral triangle. So when I say equilateral triangle, I'm saying this side, and this side are same. Yeah? This angle is 60 degree, this angle is 60 degree, and this angle is also 60 degree. Yeah? Ananya, Saranya, Samriddhi, are you guys with me so far? Yes, sir? Okay. So this is the equilateral triangle that we have. That means all the three angles are 60 degree. Now, our goal is to find out these trig function values, okay? But I'm still playing around with a geometry concept. Let me drop a perpendicular from here to here. Let's say this was stand A, B, C. I drop the perpendicular from this point and this is the point D. So, with me being playful about all these things, what I did was I had a triangle. I split that into two triangles. One is a green one that you see here, and the other one is, let's say, red one. Okay? So my red triangle is ADC, and my green triangle is Wonderful. Is ABD. ABD. So far it's okay, right? I took an equilateral triangle. Equilateral triangle means all sides are same, and hence all the three angles are also same, which is 60 degrees each. And that was not enough. I picked up one of the vertex, and from there I dropped a perpendicular on the opposite side and split that one triangle into two triangles, ABD and ACD. And I am saying that these two triangles, green triangle and red triangle, are congruent. Anybody who wants to contest this thought? I am saying I took an equilateral triangle, and from here I dropped a perpendicular, and I am saying that by doing so I split this triangle into two parts, and both these two baby triangles are congruent. Any thoughts? Anything that you don't agree to? Enoch, Ananya, Samriddhi, Dev, Saranya, Vishal. Yep.
Wait, you bisected it in the middle, right?
I just dropped a perpendicular. I did not say I bisected it. I dropped a perpendicular. So, I mean, only clue I can give you is this is a 90 degree because I have dropped a perpendicular, and this is 90 degree as well. Okay.
And you said they're congruent.
I'm saying I'm challenging you guys, saying that they are congruent. Tell me why.
That should be the same. What is that? 60 and 60 and 90 and 90? So those two angles are.
Anybody, Dev, Saranya, Vishal, I want you guys to come out of your comfort zone and fight with your teacher logically, okay? No fist fight. Enoch, any reason why I'm saying that these two triangles are congruent?
You know what two angles are, so I asked me to translate them. Wait,
Equal. So
they're right triangles.
Uh-huh.
So it can be
60, 30,
HS.
90.
Uh-huh.
Not 60, 30, 90.
What?
Vishal, what's up? You guys don't have the option of being quiet. Yep.
Sahib came up with this, but he said, since there's a 90 and a 60, that means the top one has to be 30.
And we can do the formula for that and to find the other steps.
But I mean, you are thinking two steps ahead. I'm saying think like a child, you guys are all child. I'm saying get a little younger and think about it. See, little while ago I was blabbering so much about this theorem RHS.
Alright.
Right angle triangle. When I dropped a perpendicular from here to here, I converted or transformed this angle into two right angle triangles. And for right angle triangles to be congruent, what you need is hypotenuse to be same and one of the sides to match. Your hypotenuse for this red triangle is this one, for the green triangle is this one. And they are same because this is part of the same equilateral triangle. Your hypotenuse is same and this side is any which way common. Yeah? This side is common. So that means these two triangles are congruent. Now, why I was putting all that effort to do so? Because I was trying to tell you guys that this side and this side will be equal. So let's say this is L, this is L, here to here is L, this part is L over 2, this part is L over 2. That's what I was trying to come to. Yeah? Do you guys agree or you don't?
Do you smell that? It smells like smoke.
Here?
I agree.
Yeah, you smell it, right? No, come over here. It actually smells. Yeah,
Yeah.
it smells like smoke over here.
Here? This
Like
one?
something's burning.
Okay. Maybe that
Yeah.
some fly with special flavor has got inside that. Okay. So but does this make sense?
Yeah.
Dev, Ananya, Saranya, Samriddhi, Enoch,
Maybe
Vishwa,
something
everybody?
got stuck in there, that's why it's like taking every.
Yeah. Okay. So coming back to this one, what I'm saying is, from this equilateral triangle, we found. Now let me clear the mess here. Okay. Now I'll just draw something which is conclusive in nature. This is equilateral triangle. Same side L. All angles 60 degree. and I draw the perpendicular from here to here. This is anyway 90 degree, let me not create more mess. But what we found from that is this one is L over 2, this one is L over 2. Yeah? Okay, here. So, now if you have to find out sine of 30 degree, let me zoom inside this one. I wish I had digital board. Digital boards are very expensive. I'll buy one day when I become rich. I have just zoomed into one of the triangle, okay? Yeah?
Yeah.
So this say, let's say this is A, B, C, and this point was D. So I'm talking about a triangle A, D, C. What we see from whatever circus and drama I have done is, this is L over 2 and this is L. We don't know the length of this guy yet. But our uncle Pythagoras had given that thing. It's a right angle triangle. This square plus this square will be equal to this square. So let's say this is x. So x square will be equal to x square plus L over 2 square will be equal to L square. This square plus this square will be equal to this square. Pythagoras theorem. Everybody? So my x square will be equal x square plus L by 2 whole square will become L square by 4 equal to L square, and hence x square equals L square minus L square over 4. L square minus L square over 4. That becomes 3 by 2 L square. Root 3 by 4 L square, my bad. Yeah? When you do a square root of both the sides, you will find that this x is equal to root 3 by 2 L. So this became root 3 over 2 L. Now you have all the sides. So I was talking about Pythagoras theorem, we saw application of that. I was talking about theorem of congruence, we saw the application of that. Now I'm going to go back to SOHCAHTOA, and SOHCAHTOA will tell me how much would be my sine, cos and tan for 30 and 60 degree, let's say from this one. If this is my 30 degree, this is my 60 degree because this is after splitting, right? So, let's say I'm talking about sine of 30 degree. Sine of 30 degree, SOH, so sine of any angle is opposite side divided by hypotenuse. In this is your angle, opposite side is L over 2 divided by hypotenuse by L. So this becomes L by 2 divided by L. Okay? And that becomes L by 2 into 1 over L. L and L, tic-tac-toe, you are left with 1 by 2. Sine of 30 degrees is 1 by 2. If you look at the sequence of events, whatever I did, we picked up a right equilateral triangle, dropped a perpendicular from that, and we saw that by dropping a perpendicular, I am splitting this into two congruent right angle triangles. So if these two triangles are congruent, that means this side and this side will also match. And hence, if this whole thing is something L, this is L by 2. And then we took a zoomed in version of this particular right angle triangle, and now we are playing with that. So we have this as L, this as L by 2. Applied Pythagoras theorem to find out this length in relation to this and this, which is root 3 over 2L. And now we are applying SOHCAHTOA. Make sense? Make sense? Or doesn't make sense? Enough.
Yes, makes sense.
Make sense? Now somebody has to tell me, I am totally lost. I am delusional right now. If I have to find out what will be the value of cos 60 degree, who can tell me that? Cos 60 degree, I forgot. I am having short-term memory loss. Can somebody tell me how do I get cos of 60 degree? Ananya, Samriddhi, Sahanya.
Is it 1/2, sir?
I'm sorry, sir?
Is it 1/2?
It could be 1/2, but you have to actually teach me how did you get to that. I'm kind of taking revenge from all my kids. If I'm teaching you something, you have to teach me as well. Tell me how.
I remember my teacher telling me,
Okay.
like,
Okay. You have everything right in front of you actually. Yeah.
It's because cos is like reverse from sine. So if sine 30 is something, then that's the same as cos 60.
That's something that you have remembered based on your memory. If you have a situation like me, where you have a short-term memory loss, your picture here, picture speak 1,000 words. Yes, Vishal. Yeah, Vishal, go ahead. If you're talking, I cannot hear you. Might be a technical glitch. Vishal, can you try talking once? I could not hear you actually. No. So, guys, I'm old enough to say I cannot see things. But if you guys are confident about your eyesight, look at this. You have a right angle triangle with one angle is 30 degree, one angle is 60 degree. Now you talk about this angle. Apply SOHCAHTOA. What is SOHCAHTOA? Ka. Cos of any angle is adjacent side by hypotenuse. Here in this triangle, you have a 60 degree angle, any which way. Adjacent side, if this is the angle, this is our opposite side and this is adjacent side. Adjacent side is L over 2 divided by hypotenuse. So L over 2 divided by hypotenuse, if I convert that, it becomes this one and this one tic-tac-toe, 1 by 2. So what you said enough, that was perfectly fine. I was telling you guys that don't rely on your memory. There is a mathematical way to get to it. Yeah? Saranya, are you angry with me, beta? No response? All good? Ananya, okay?
Yes, sir.
Biswa, is it clear? Dave, no problem, beta?
yes.
Okay. So now see, basically if you look at this whole gymnastics that I did for last 10-15 minutes, I just played with one equilateral triangle and that will help me find out sine of 30 degrees, sine of 60 degrees, cos of 30 degrees, cos of 60 degrees and tan of 30 and 60 degrees as well. If you can find out sine cos, you can find out tan as well, because we took this right equilateral triangle and from this we manufactured this right angle triangle with 30 degree and 60 degree. Whichever angle you are trying to find out the trig function value, you will just pick that angle, apply SOHCAHTOA. Yeah? Are we all okay so far? Okay. Now let's go to make our life a little more interesting. Samriddhi, are you okay with that so far?
Yes, I'm okay.
Okay. Now, if I say sine and cos of 30 and 60 is fine, how about 45? How do we find out sine, cos and tan of 45 degrees? Some creative ways. Have you guys come across this before? No?
I think maybe, I don't know. I'm trying to remember.
Okay, just tell me the value first, then I'll tell you the trick or technique. It's not a trick, it's a very simple technique.
Isn't tan 45 just 1?
One more time?
Isn't tan 45 just 1?
Yeah, how about sine and cos? One over root 2. Sine 45 is 1 over root 2, cos 45 is 1 over root 2. And I hate to ask kids to memorize the values. I memorize it because I probably have done it enough. It's been 30 years of fun. Okay? Alright, let's look at it. If I'm dealing with an isosceles triangle, I'm saying this angle. Now let me make it a little simpler for you guys. Let's not overburden you guys with a lot of congruence concepts. Let's say I took a right angle triangle, and on purpose I made sure that this side and this side are same. So what I did was I took a right angle triangle.
Oh, it's a 45, 45. Right?
So that way this is 45 and 45. Okay?
And then the last one's 90.
This one is 90. So I drew a 90-degree angle, and then when it came to picking up the length of the sides, I made sure that these two sides are same length.
Oh, so then it's x, x, and then x root 2, right?
Yeah, so if this is, let's say, this is x, this is also x,
No,
this will be
x root 2.
x root 2,
Other x root 2.
x squared plus x squared, let's say this is L, or I'll call it h, equal to x squared. So x squared equal to 2x squared. Now see, I have a very unique problem that I deal with at times.
So
Yeah,
square
you were right actually. I mean, I was not able to process that information. So if this side is x, this is also x. That is how we have drawn it. And then this side will be
root 2.
root 2x. Now apply your Sukha. What is the sine of 45 degree? Let's say I pick this as my 45 degree. This angle I like so much.
So then x
X over
root 2.
opposite side by hypotenuse.
And then x and x.
So I will keep on bugging you guys by repeating this thing, okay? So sine is opposite side by hypotenuse. My opposite side is x, my hypotenuse is root 2x. Have fun. Tic-tac-toe, you're left with 1 over root 2. Same thing, cos of 45 degree will be equal to, if I am picking this angle, let's say this time we will choose this angle. Doesn't matter. Cos of 45, so this is my angle. Cos of 45 says cos. Cos is adjacent side by hypotenuse. This is my angle. What is my opposite side? This one. What is my adjacent side? This one. So that is also x over hypotenuse, root 2x. 1 by root 2. Yeah? And sine over cos is 10. You can say, you can apply this, or you as we all know, sine by cos is equal to 10 of that angle. So sine by cos 1 by root 2 by 1 by root 2 will give you a 1, or you can look at this here. 10 of 45 degree. Let's say I'm picking this angle as my angle of preference. Opposite side by adjacent side. X over x. I cannot get anything other than 1. Is everybody with me so far? Make sense? And here, since this is your first class, I mean, one thing I keep telling all the kids, I know some of the kids are afraid of me right now, that I will repeat something that I have repeated so many times. I'll not talk about that today, maybe some other day. But what I insist on is, in this class, whenever we are learning something, the fear of being wrong has to be kept aside. Don't even worry about it. You did something, you share the answer, you share the approach. If it's right or wrong doesn't really matter. Okay? If it is right, I'll say yes, this is right. If I found some opportunity for correction, I'll let you know. Ultimately, the benefit that you'll get is whatever you knew, you'll either get confirmed, or if there's an opportunity for correction, that gets corrected. So then, net, there's nothing to lose, right? So, and I'm not sure who all will get a chance to even meet each other. So if you're thinking that what my friends will think, if I'm making a mistake, don't even think about it. That fearless learning is what I prescribe, and that's what we'll keep practicing as well. Alright?
Yes, sir.
Okay. Alright. So what did we do so far? sine of 30, 60, cos of 30, 60, tan of 30, 60, and then sine, cos and tan of 45, we found out. Not by memorizing it, though I ended up memorizing by doing it so many times, but when it comes to you guys, you have to only keep two pictures in your mind. One is the equilateral triangle for finding 30, 60 thing, and one is this isosceles triangle with 45 degrees. Isosceles right angle triangle, okay? That will give you enough clue to derive it at run time. I took a little longer to break it down so that everybody can follow it, but then when you are doing that scribbling by yourself, it will take you 30 seconds to derive it, even if you forget, okay? Alright? So before I move on, Ananya, Saranya, Dev, Samriddhi, Viswan, Vishal. Is everybody okay? Nobody is mad with me so far? Nobody is getting tempted to pull my hair? No? Okay, alright, then we can continue. We have 15 more minutes and we'll learn one more concept and then come back to the things that we have done so far to see how relevant it is. So we will talk about unit circle. Unit circle, so before I go any further, what do you mean by unit circle? I mean, what is your acquaintance with unit circle?
I know it's like the expanded version. It's like this like big circle with all like the rational roots or something. I don't know. It's like in Greek.
Keep thinking. No.
Big circle.
Okay. Anybody else in the class? Give me some definition of unit circle. As I said, I have a very unique problem of short-term memory loss. So right now I forgot what is unit circle. Somebody has to help me recall that.
Is that on the coordinate thing?
It's a circle found in the origin.
Circle found the origin.
It's like circle like full of numbers. I don't know.
No, it's okay. No fist fight. Ananya, Dev, Samriddhi, Vishal, anybody? What is a unit circle? Saranya, anybody? It's okay, but anybody, give it a try. I'm shamelessly acknowledging that I have a short-term memory loss. I forgot. Somebody has to give me the jump start. No?
Can you repeat it?
I'm asking you guys, what do you mean by unit circle? Very simple question.
Like where the y-intercept is? Like where the line crosses?
Okay.
It like starts from the origin and it just like makes like 360 around and you can see where the points are.
Okay, you guys are overthinking about things. As I keep on claiming and sharing that I'm a very simple person, I said unit circle. Unit and circle. A circle with radius as 1. That's it. A circle, see, how do you recognize a circle? Circle has very simple identity, right? See, I keep saying that I'm a simple person. Same way, circle is also simple, right? You can see my face. It looks like a circle right now. Almost like a circle. Okay? So, coming back to this one. I'm saying that a circle, how do we recognize a circle is? We just need to know two things. One is, where is the center and how much is the radius. If we know these two things, it's more than enough to locate the circle and do anything and everything possible with the circle. Yeah? You just need two things. Center, where it is located, and how much is the radius. Now, so when we talk about unit circle, it talks about a circle with radius of 1 unit. Be it 1 centimeter, be it 1 inch, be it 1 meter, be it 1 mile, or be it only this much. 1 millimeter is a little too less. Okay? So if I'm talking about a unit circle, I'm talking about a circle with radius as 1. Now the question here is, okay guys, here, everybody here. So now the question here is, why even I'm talking about unit circle? Because unit circle is okay. Let me give you guys a little bit of background. If we talk about trigonometric functions, right? We talk about a right angle triangle and the angle it makes, and we can go from 0 up to 90 degrees only, because we are talking about right angle triangle. So if I have to find out the value of any trig functions, I can go only up to 90. The time I cross 90, I don't know what to do using the basic trig functions or SOHCAHTOA. So that is where unit circle comes handy and gives us that extra ability to deal with angles or value of trig functions more than 90 degree. Find out the value of trig functions for the angles more than 90 degree. Okay? Was that a digestible speech before I get to the mathematics of it? Something more interesting going on there?
It's locking up because my phone is sliding because there's no friction between the table and the glass.
Okay. That's something to do with physics. We'll focus on math for now. Okay, let's come here. So everybody here. So just to give you guys a prelude of why we are even talking about unit circle, because unit circles, if you look at the right angle triangle and the circle side by side, you will see that by applying SOHCAHTOA, concepts, you can go up to 90 degree only, because this aligns with the right angle triangle, and we can deal with trig functions only up till the angle goes to 90. The time it goes beyond 90, let's say this angle is 110 degrees. This is not even 90 degrees. This is not a right angle triangle anymore. We cannot apply trigonometric concepts. This is where, now if you imagine this and say, if I find out this angle and find out the value, we'll talk about that in detail. Let me just tell you one thing. If I'm talking about unit circle where radius is equal to 1, okay, radius is 1. Unit circle tells us that x and y, if I'm looking at, okay, guys, here. Unit circle is to be visualized in the coordinate plane, and the center of the circle coincides with your origin on the coordinate plane. And unit circle says that any point that you pick up along the perimeter of this one, the y coordinate will be, x coordinate will be cos of theta, and y coordinate will be sine of theta. So if I keep revolving around this unit circle, if I make 5 iterations, meaning 360 degree into 5 plus 30 degree, I can find that sine of this angle or cos of this angle. Unit circle helps us achieve that. Okay, we will talk about that. We'll go into the detail and see why we are even talking about cos of theta or sine of theta as a coordinate for each and every point on the circle. Okay, but the gist of what I'm trying to say here is that if you are talking about a unit circle, this is an extension of the trig functions that we have learned with the basic right angle triangle. Right angle triangle has a limitation that we cannot go beyond 90 degree. This one tells, if you have to find out, let's say, sine of, let's say, sine of 405 degrees, okay? You can never draw an angle like this with a basic triangle, okay? Sine of 405 degree, you will say, okay, fine. 405 is how much? This is 180. This is 360 plus 180 is 540. Okay, so we are talking about 405. So one complete loop will make 360 degree. And if I'm talking about 405, meaning I'm going 45 degrees further. So after making one complete loop, you're talking about only this 45 degree. So whatever is the value of your cos theta, I mean this x is what your value of this would be. So this will be equal to sine 360 degree, which is 0, plus sine of 45 degree. This is anyway making complete loop, and here it's 0. This will be 1 over root 2. So sine of 405 degree, 405 will be 1 by root 2. So far I have not decoded this for you guys. I am just telling you that, okay, if you have to find out any trig function for a higher theta, you can use unit circle, and that's where it gives us that ability. Now let's dig little deeper into it to understand why even I am talking about all this. Okay. Only one takeaway for you guys is, with basic right angle triangle, we can find trig function values for angle up to 90 degree. If we are going beyond that, that is why unit circle helps us to get trig function values for much higher degrees. Is that a good starting point, or you guys want me to deliberate this any further? Everybody okay? All right. So now let's look at unit circle in depth. And you will say that I am claiming that let's look at it in depth, but there is no depth here. It's a very shallow concept that you guys already know. Now let's look at it. Guys, here, everybody here, please. In 10 minutes we'll be done. I'm not saying that we should not have fun in the class, but let's focus on it a little bit. Let's say this is my circle, okay? I know an egg is not supposed to be called a circle, but let's assume this is a circle. And here, the origin of the center of the circle is coinciding with the origin of the coordinate plane. This is my x-axis. This is my y-axis. Okay. I am picking up a point here on the perimeter and joining this center with this point. Okay. And saying that this is making angle theta with a positive x-axis. Mark my words, I am saying this is making angle theta with positive x-axis. Because if I say negative x-axis, I am talking about this angle. Okay. Alright? So far okay? I mean, barring my drawing skills, you guys are going to follow this, right? Mm-hmm. Okay. Now, what I was trying to say, I mean, just a few minutes ago I was saying that if I have any point here, the x at any point on the perimeter, the x and y coordinates will be cos theta, comma sin theta. That's what I was forcing you guys to believe. Let's keep aside the force part of it, okay? So this is a coordinate plane, right? Now whatever is this one, this will be my x coordinate, x comma y, that will be my x and y value. Is that okay? And when I am talking about x value, I am essentially talking about here to here. When I am talking about the y coordinate value, I am talking about this as y. Yeah?
Yeah.
And how much is this length?
Which one?
Here to here. Let's say this is O, and this is I picked up a point P. What is this length O to P?
X squared plus y squared.
It is 1. It is 1 because I am talking about unit circle again.
Oh, because the radius.
Because my radius is just 1.
Oh.
Yeah?
Oh.
Yeah? Because I'm talking about unit circle right now. Unit circle, simplest definition of unit circle is the radius is 1. That's why it's called unit circle. If the radius is 200, probably I'll call it 100 circle. 1000 circle, million circle also if needed. Okay? Let me not distract you guys. Coming back here. Okay? So 1 is my radius, and this is x and this is y. So what is the value of x? Let's go back to our SOHCAHTOA concept. SOHCAHTOA. And see how annoying this could be, right? If you hear it from me so many times, you don't have to memorize by yourself. I'll get you guys tired of SOHCAHTOA so much so that you don't have to practice by yourself. Okay. Now, here, I know this is my. Now let's look at this. This is O, this is P, and this is Q, point Q. Now I'm zooming into this triangle OPQ, triangle OPQ, and this is my theta. Okay. Now let's look at the relationship between these. What is my sine theta? Sine theta, sine of this theta is y over hypotenuse. Y over hypotenuse, which is 1. What is my cos of theta? Cos of theta, this is my theta, so I adjacent by x over 1. Now look at this. This is what I was saying, right? My x is equal to cos theta, y is equal to sin theta. X and y I replaced. I'll give you guys 30 seconds to digest this. So let's look at the sequence of events. What did I do? I drew a circle here saying this is a unit circle, meaning radius is 1. I randomly picked a point P on the perimeter and dropped a perpendicular from that onto the x-axis. And joined this point and the center. This is making angle theta with the x-axis, positive x-axis. So when I drop a perpendicular from here to here, this is my x and this is my y. That is how my coordinates were x and y. Now we are looking at what is my sine theta and cos theta. We are relating this unit circle with the sine cos, trig functions understanding. What is my sine of this theta? That is y over hypotenuse, which is 1. That is y. Sine theta is y. Cos theta is what? X over 1. That is x. So my x value, my x coordinate value is nothing but cos theta. My y coordinate value of that point is nothing but sine theta. So I just replace that. This becomes a universal rule for us, that if you're talking about a unit circle, any point on the unit circle, if you are here, you will say, okay, the x and y coordinates will be cos theta, comma sine theta. And this theta is nothing but angle with the positive x-axis. So you are talking about here to here. Let's say this angle is 45 degrees from here to here, this part. You are talking about 180 plus 90, that is 270 plus 45, 315 degrees. Okay? So you will say, okay, what you will do is, you will find out, see, ultimately x is this part. So now visualize this. Okay, so what we'll do is, we'll deal with this a little bit more in the next class also. I don't want to overwhelm you guys with a lot of things. What I'm saying right now is, the only takeaway so far is, if I'm talking about a unit circle, I'm talking about a circle with radius as 1. And then, second thing is, any point along the perimeter of a unit circle, this will be my x and y coordinate. Cos theta, comma sin theta. That's what unit circle says. So that helps you find out the value of different angles. What we'll do in the next class, we'll try finding out the value of 315 degree, 460 degree, 650 degree, 1285 degree, whatever. And see how this unit circle comes or gives us that wings to fly beyond 90 degrees when it comes to finding out the value of trig functions. Is that okay? So we talked about, we did a recap of what is Pythagorean theorem. We talked about, or did a recap of what are the theorems of congruence. We talked about SOHCAHTOA. Then we talked about how do we derive, applying geometry and trigonometry combined, how do we find out the value of basic trig functions, 30 degree, 60 degree, 45 degree. And then we came here when we talked about unit circle. And then from that, only takeaways, any point along the perimeter that you pick up, the x and y coordinates will be cos theta, comma sin theta, and that theta is nothing but the angle that it makes with the positive of x-axis. With that being said, we'll pause here. Any questions? Anything that was cryptic, boring, annoying, tiring, let me know. Anything. Anything that is not clear also. I mean, that is more important. I mean, I know I'm just pouring a lot of creativity, unwanted creativity. But on a serious note, I'm just trying to find out if there was anything that was not clear to any of you. Ananya, Dev, Samriti, Vishwa, Vishal, Ina, Saranya, anybody. And be fearless with me, okay? I mean, even if I look scary, I'm not scary. Yeah? Is everybody okay? Was it clear? Okay, so then after I'll let you guys go. I'll upload the video of the class which you guys can watch later. Recap whatever we did today, and then we'll muddle the water a little bit more in the next class. We'll try finding out the application of this unit circle trigonometric functions combined and see how this is helping. If you guys find that this is not helping, we will not focus more on this then. Okay? Alright. Thank you everybody. Have a good night. Have a good dinner. Take rest. We'll talk again. Alright. Bye bye. Bye bye. Bye bye.